Look, everyone, there's a big guy coming out of there. You usually take the subway. Have you ever thought? Deep subway, more than 10 meters of subway, and tens of meters wide highway tunnel are dug out by what machine? In fact, it is completed by the machine in front of you. It is called Shield Tunnel, boring machine. Let's see how it works. It's 160 meters long, weighs 2,800 tons, and has a total power of 9,000 kilowatts. It can generate a maximum thrust of 20,000 tons. These figures are approximate. It's made up of three main components: the cutter in the front, the conveyor, and the belt in the center. At the back is the tunnel tube sheet erection machine. Let's see how it works. This is a picture of it at work. In the front is the rotating cutter plate. There are a lot of blades on the cutter. The blades are not like knives, as you know. This is called a blade, but it's actually round. It will switch to the most suitable blade according to the different hardness of the ground. It's made of tungsten steel, which is very hard. The power to move forward comes from a row of hydraulic jacks behind the blade. The base of the jacks is supported on the finished pipe. When it works, it sends out force slowly, making the cutter plate advance slowly. The rotating cutter disc drives the dense, sharp blades. Under the continuous advancement and vibration, the debris and soil will be peeled off and fall down continuously. Then the screw conveyor underneath will transfer the excavated debris and soil to the conveyor belt at the back through the pipeline for transportation. After the excavation has progressed at a certain distance, the excavation will stop due to the length of the hydraulic jacks. The next step is to build the ring of tubes. A complete tunnel ring is made up of a number of reinforced concrete pieces. These pieces are prefabricated to specification at an outside prefabrication plant, and then transported into the tunnel by tunnel trucks. At this point, the hydraulic cylinders that drive the cutters forward are retracted in sections. The hydraulic jacks vacate the installation position of the tube sheet, and then the robotic arm machine grabs the tube sheet and installs it. Finally, the hydraulic jacks push the pieces into place. The two pieces of pipe are connected using a mortise and tenon and rivet method. Finally, grouting is used to fill the gaps on the outer wall of the tubes in contact with the mountain to complete the project. The shield can only travel 10 meters a day. Depending on the hardness and softness of the soil, the distance traveled fluctuates. Almost all of this can be done by the central control room. I can't help but feel that the technology is too powerful. Lastly, I would like to ask in the comments section, does anyone know how the shield machine can make a turn?